Okay, hello everybody. My name is Yangyang and my supervisor name is Guandong Xu. I come from UTS. Now I will present my paper, which is published in ESEM 2020. Let's start. The title I want to share in my paper is Performance Prediction for Configurable Software through Adversarial Learning. Today, this paper, in order to show this paper, I will to introduce this 5 sections. The first one is background, the second is motivation, and then method, experiment, lastly, conclusion. Okay, firstly, I introduce the background. In this paper, I want to solve a problem about configurable software. Yeah, and so as we can see from this picture, we can find from the table we can find in a configurable they have 10 options, and 8 options is binary, and the left 2 is left 3 is a continuous value. So we want to use this configurable to predict the software performance. And then how about this motivation? Okay, the motivation in this paper, we want to focus on predicting software performance by using a small configuration sample. But current approaches just concentrate on some traditional machine learning methods, such as CAT, SPLC approaches. These traditional machine learning methods usually require a very large amount of training samples. So these methods heavily rely on the high quality samples. So this is not convenient and is not easy to satisfy in real world. So in our method, we want to propose the Perf-AL to address the problem through adversarial learning. The generator network output predicted values as close to the ground truth label as possible, and the adversarial network identifies and distinguishes the predicted values of the generator network from the ground truth value distribution. Maybe the question is why we use adversarial learning? The reason is that discriminator as a teacher judging predictions of ground truth to enable the trend distribution close to ground truth. Yeah. So that the smallest configuration samples finish the best performance. Okay, then next I will introduce my proposed method. The proposed method, as you can see from this picture, our method consists of generator network and discriminator network. So let's talk about the generator network firstly. In the generator network, we want to output the performance. Yeah, and so we want in this network we want to use dropout L1 or L2 regulations to finish the overfitting problems, and the loss function is surprise loss. Yeah, I give the object function. And next I will introduce the adversarial learning. In the adversarial learning, we want to find which is the real performance and which is the fake performance. Yeah, so then I can combine the adversarial network and the generator network together. We use alpha. Alpha is the parameters to control this model is GAN or not. If alpha equals 0, this is GAN model. If alpha equal very big, this means this is a general network without GAN. So this is our algorithm. In our algorithm, we want to use negative log djx instead of log 1 negative 1 minus djx. Yeah, and then we firstly trained the D network and then trained the G network. This is inspired of GAN in the number of training iterations. Okay, then I design our experiment. In our experiment, I use seven database. That says 4 datasets is binary configurations options, and 3 datasets with both binary and numerical configurations options. Yeah, so as we can see from this table 2, some datasets conclude binary, and some datasets conclude both binary and numerical. They also have some configures in the datasets. Yeah, so I propose the 4 questions. The first question is: does our proposed approach improve the performance in the binary options? Yeah, the answer is our approach performs best in binary options on set datasets. And the second question is: how about in binary and numeric options? Yeah, the answer is our approach perform best in binary and numerical options on datasets. And the 3 questions is that what's the contribution about the adversarial component? Yeah. Specifically, what about the prediction accuracy of deep network with or without adversarial learning? The answer is adversarial component improves the prediction accuracy with fewer samples. The last question is that what kind of regulation should be used to approach the best performance? The answer is compared with L1 and dropout regulations, L2 approaches the best performance in our experiment. Okay, let me show my experiment results. As we can see from the table 3 or table 4, in the table 3, we show the binary configuration, and the tab 4 shows the binary and the numerical configuration options. We can find that compared with deep method and the decard method, our proposed method have a best performance in both binary configuration options and numerical configuration options. So we answer the question 1 and question 2. And question 3, what is the contribution about adversarial learning? Yeah, we can show the 3 pictures. In the left picture is earlier iterations. We can find that the red one is Guandong, and the blue line is our predictions. So in the left picture, we find the gap is very bigger between Guandong and the prediction. But in the in the middle picture is a deep network. We can find this is not good than the right pictures, because right pictures use GAN, but the middle pictures without GAN. So GAN have a good performance, and GAN play a important roles in the training processes. Yeah, as for the question 4, what kind of regulations should be used to approach the best performance? I use dropout, L1, L2 regulations, and I show the results in table 5 and table 6. We can find that from the table 5, we can find L1, L2, and dropout. The L2 has good performance, best performance. So I want to put L2 techniques into our proposed model, into our generator network. Yeah, and we'll find our generator network improve a lot. So lastly, I will give our conclusions. Our proposed adversarial learning approach captures the correlation between the prediction and ground truth, forcing the distribution of the prediction and ground truth to be close to each other. The second conclusion is that our proposed Perf-AL model is able to work with both binary and numerical configuration options. The third conclusion is that our experimental results on 7 public real-world datasets demonstrate that Perf-AL outputs state-of-the-art software performance prediction methods. Okay, this is our paper presentation. Thank you, everybody.